Hi y'all, this is Mrs. D, and today we're going to learn how to write and graph equations from tables. So let's go ahead and get started. So we're going to decide if the relationship between the x and y is additive or multiplicative first. And we've talked about this before. The additive relationship is when you have to add to get from x to y each time, and it's going to be the same value that you add every time. Multiplicative is when you have to multiply the x value with a number to equal the y value. So my first table here, my x's are 2, 4, 6, 8, and my y's are 5, 7, 9, and 11. So we're determining between my x and my y, so if I'm going this direction each time, what am I doing each time to get from my x to my y? Well, 2 doesn't go into 5 evenly, so I'm either multiplying by a decimal or I'm adding 3. 4 and 7, also I can add 3. 6 to 9, I can add 3. And 8 to 11, I can add 3. So we can see here that we're adding 3 each time. For our second table, I want to also find my relationship between my x and my y. So again, I'm looking at how I can get from one to the other. Now this one, 2 goes into 4 by multiplying by 2 or adding 2. 4 goes into 8 by multiplying by 2 or adding 4. 6 goes into 12 if I multiply by 2 or add 6, and 8 goes into 16 if I multiply by 2 or add 8. So you can see here that the consistent increase is by multiplying times 2. That's what I do each time. So this one is times 2. So what is the relationship in each table? Well, the first table I'm adding 3, and the second table I'm going to multiply times 2. So now we're going to use the relationship to write an equation of y in terms of x. And this is pretty typical. Usually you want to have your y equals x plus or times something. So our first one was our adding 3 each time. So to get from the top to the bottom, I added 3. So in this case, x plus 3 equals y. Now you can test this out if you want to, and you can take your x values here, 2, 4, 6, 8, and plug it in for your x in the equation. So if I plug in a 2, 2 plus 3 equals 5, which is what my y is whenever I have 2 and I plug it in, I get y equals 5. Same thing for 4, 6, and 8. So let's write our equation for the other table, and in this case we decided that we were multiplying by 2 each time. So I'm going to multiply my x times 2. If you remember, we don't need a symbol there. We have a letter and a variable, we have a number and a variable side by side. So I don't have to write anything in between them. It's understood to be multiplication, and that's going to equal our y. So again, I can take any of these numbers in my x values and plug it in, and I should equal the y value that goes with it. So if I were to plug in 2 here times 2, I get 4. Now these equations that go with these tables are helpful whenever you're trying to find maybe a really large number. So let's say they give me this table to start out with, but they want to know what y would equal if x equaled 80. So if x equaled 80 in this first one, I would plug in 80 for x, and I would know that y equals 83. And then same thing for my other one. If I were to plug in an 80, 2 times 80 means that y would equal 160. So using an equation to go with your table is helpful if you're trying to solve especially larger numbers, or if you're trying to see the pattern. Now sometimes we have a table and we need to use that table and the equation to complete the ordered pairs, and then we can graph them. So let's look at our table here. This table is an additive relationship because you notice I'm adding 2 to x to get my y every time. So let's fill in the rest of the table. So here I'm going to plug in, instead of 1, this time I'm going to plug in a 2. And 2 plus 2 equals 4. So now let's write our ordered pair. So that means that if my x value equals 2, my y value is 4. And then we can do the same thing for the others. So instead of an x in my equation, I'm going to plug in a 3 this time. 3 plus 2 equals 5. So my ordered pair is 3, 5. And if you follow here, y is the answer to my equation. X is the number that I plug in. So the next one I have a 4, so I'm going to plug in a 4 for x, and 4 plus 2 equals 6. So my next ordered pair is 4, 6. And my last one is 5 plus 2. 5 plus 2 is 7. So my ordered pair is 5, 7. Now we want to take that information and graph it right here on our graph. So my first one, I'm going to go ahead and label 1, 2. And sometimes you'll notice that we only label maybe every other one. And that just means that the ones in between are my odd numbers. So my first ordered pair right here is 1, 3. So I'm going to go right 1, up 3. There's my first one. Then I'm going to go right 2, up 4 for my next one. Right 3, up 5, right 4, up 6, and right 5, up 7. So because I'm increasing by the same amount in every single equation, I'm going to have a consistent line here. Okay, these dots are going to go in a consistent line. I could even fill in the next ones without even using my table because I've already got the process. So that means I could tell that at 9, if x equals 9, y is going to equal 11. I can use that using my equation or my graph. All right, so now we're going to use the table equation to complete the order of pairs and graph them, but this time we're going to be doing a multiplicative table. So let's go ahead and fill out the rest of the table. So multiplicative means that my x value is going to be multiplying by the same number every time. So you notice here, instead of an x for the first example, we plugged in a 1. That means for the next one, I'm going to do 2 times 2. I'm going to plug in a 2 for that x, and 2 times 2 is 4. So now I can write my next ordered pair. That means that if x equals 2, y equals 4. So my ordered pair is 2, 4. Now I'm going to plug in a 3 for x. 2 times 3 is 6. So my next ordered pair is 3, 6. Now I'm going to multiply 2 times 4, which equals 8. So my next ordered pair is 4, 8. And last, I'm going to plug in a 5 for x. 2 times 5 is 10. So my last ordered pair is 5, 10. Now we want to graph these on our graph just like we did for the last one. So I'm going to label my 2, 4, 6, 8, 10 just to make it simple. 2, 4, 6, 8, 10. So now my first ordered pair is 1, 2. So I'm going to go right 1, up 2. My next ordered pair is 2, 4. So I'm going to go right 2, up 4. Then I have 3, 6, 4, 8, 5, 10, and so on. So that means that 6 would be at 12. So one of the things I can show you, if you remember from the graph we just did on step 3, that one we added 2 each time. So when x was 1, y was 3. When x was 2, y was 4. When x was 3, y was 5. When x was 4, y was 6, and so on. So you notice, if you see the yellow in comparison to the blue, the blue is increasing at a faster rate, and that's pretty typical of multiplicative relationships. They're going to increase faster than an additive relationship. So that's just one thing I wanted to point out to you. So let's go back over our steps real quick. So first we had to decide if the relationship between the x and the y is additive, which means we were adding, or multiplicative, which means we're multiplying. And if you remember, in both situations, we want to multiply or add to the x in order to solve for y. Then we use the relationship to write an equation of y in terms of x. And last, we were able to use a table equation to complete the ordered pairs and then graph each one. And this, again, when you use your equation, you can actually solve for y no matter what x equals. So if you still need more help, you can watch this video a couple of times, do some practice problems, and then be ready to ask any specific questions. So thanks for joining me on how to write and graph equations from tables. This is Mrs. D signing off. Have a great day.